All right, pop quiz. Name this quote. Who said, "Everything fails all the time"? What a quote to be remembered by, right? Werner Vogels, Amazon CTO. And it actually caught on like wildfire. You can type it in Google and you'll see his face and name come up. Why? Because it's so behind the heart of all IT systems and everything Amazon Web Services is designed to do. That's what this nugget is all about. It says virtual private cloud, but it's actually turned into high availability across the board, designing for high availability. Now, there is a lot to get through in this nugget, so let me hit the high points. We're going to be looking at Direct Connect. How do we make that highly available, or what's the best design practices for it? We'll look at HANAT, as well as application and session state high availability. Here are your do I know this already questions. So pause the video, read them over. But I would say this is honestly an exception to the rule. Usually I say just, move on if you already know the answer to these questions. But I have a feeling this nugget is going to be so rich with information on high availability, I would watch it even if you do know the answer to those questions. Let's get started. All right, let's start off with AWS Direct Connect. Okay, quick survey. Who here can tell me what Direct Connect is? Oh, wow, a lot of people. Yes, you, sir. Come on up.
Direct Connect is it's connecting directly to Amazon Web Services.
Yes, that is accurate. Oh, yep, yes, ma'am. Come on up.
Direct Connect is it's a partner data center that allows you to co-locate your equipment and connect directly to an Amazon Web Services data center, also known as an availability zone, via fiber optic cabling.
I can't do it anymore. I'm telling you, you talk to yourself all day, you would do this too. My own little schizophrenic pals that I have here. Yes, ladies and gentlemen, that is accurate on Direct Connect. It is partner data centers allowing you to put your own equipment in and connect directly to a availability zone of Amazon of your choosing. Now, the beauty of this is once you go into a partner data center, you can even get your own connections coming in there. I don't know how many of you have seen a data center before. If you haven't, go on a tour. It's a trip. It really is divided into two major pieces. Your stuff. I'll just put your stuff over here. And then over on the left-hand side is the carrier stuff. That's really all there is to a data center. And then throw in a whole bunch of power for fun to make sure that if the grid goes offline, you've got power running that data center. And you got all these cables of all these different carriers of varieties coming into this data center. And essentially, you purchase your own links to these different carriers. I mean, this is it. This is a data center in all its glory. All these different carriers, you buy your own little links to whatever carriers you want, right? So how does this work? Well, in this partner data center, which looks something like this, you can bring in your corporate office, your regional offices, your house, whatever you want. Let's just say you decide on Sprint, right? Then you would connect your corporate office, regional site or whatever via Sprint. Then you would, in this data center, say, okay, Sprint, I would like you to bring in my corporate office. Here's Corp coming in through you, and then I will buy a connection from you directly into my rack of equipment. And again, you don't even have to have a rack of equipment. You could just go direct right here to the Amazon Web Services router and now have a private link into this. Why would you do that? Well, a couple reasons. One, privacy. Two, you can get a dedicated bandwidth that is yours. It's not just internet connection. Three, you might have cheaper costs because you might just get a 1 gig link where you are doing all kinds of replication or whatever you're doing from your corporate office or your own equipment that you have here. And let's just talk about the equipment you have here. I mean, think about it this way. If you were to go buy, 30 terabytes of storage in S3, the monthly cost could be absurd. I mean, I don't want that 11 nines of availability on S3. I just want to throw in a little NAS box that has space for backups and has 30 terabytes of RAID 5 disks or something. So you can go throw that into the data center. There's your NAS and allow that to communicate to your instances running in AWS over this little private link. That's what we call Direct Connect. Pretty cool, right? So let's talk about how we make this highly available. Well, this is a single connection to Direct Connect, not a high availability design, but you can go dual, meaning AWS will dedicate multiple routers redundantly in the partner data center to your routers, which you would have to buy and make redundant, and your connection. So instead of saying Sprint, I'll take one, you'd say Sprint, I'll take two, the two for one deal, and bring my office in that way. So I have full redundancy all the way through. That's really all there is to Direct Connect redundancy. Other item of note is that you do have the ability to do VLAN tagging over Direct Connect, meaning this does support VLAN tags. Why is that cool? That is not just cool, that is awesome, because I can create these own little VLANs where I could have, my public subnet coming across here, because, you've got your internet connection, right, coming into the region, but I may not want to have my devices here go out through the internet, to reach their public address, so I could create my own little public VLAN here, feed that through, so the devices in this partner data center and my offices down here all end up going through this connection to reach the devices rather than the internet, even though I'm accessing quote-unquote public IP addresses. Then I could have private VLANs, and it's, again, let your mind wander on how would I design this connection to be optimized with no limitations on VLANs. Now let's talk about another component of high availability, and that is the elastic network interfaces. Every single time you spin up an instance in AWS, it will start with ETH0. That is the built-in network card of the instance, or virtual network card of the device, right? You cannot move that. It is fixed to that instance, which means if that instance goes down in a blaze of glory, or the host server that it's on, you lose the network card with it and everything goes down. That's bad. Using elastic network interfaces allow you to move the interfaces quickly, meaning the interfaces are detachable. So what you would do is spin up your instance, create ETH1. Actually, I think in another nugget in this series, I show how to do that on an Ubuntu instance. You create ETH1 and you start pointing your services to that ETH1 network card. Now, when the server goes down in a blaze of glory, you can have scripts on your servers that move that ENI to another box. So maybe you've got a box either already booted or that boots. We'll talk more about how we do that in just a moment. But you boot a box up, and then you attach the ENI, the Elastic Network Interface, which includes the Elastic IP address, includes private IP addresses if that's what you have assigned on there, avoids DNS issues because you might have mysite.com pointed to that IP address via DNS, and if that IP address moves, DNS doesn't care. Right? It just comes into the new box. Simple fallback. Once this blaze of glory server comes back online, we can just go in and move that ENI back to that device, and we're good to go. Only thing worth mentioning, actually, it was one of the do I know this already questions. This does only work within the same availability zone, same subnet. So if you have instance in another availability zone, you cannot cross that boundary with the Elastic Network Interface. As your presence in Amazon Web Services grows, you'll typically find yourself moving more into private servers in addition to public servers. Like maybe you start with a web server and you're like, well, that worked well. So let's split it into some database servers and storage servers and application servers that support those web servers. And so you have these instances or servers that are running that you don't want publicly exposed to the internet via Elastic IP address, but that need internet access to do updates and patches and whatever else you download onto those servers, right? That's where Amazon Web Services provides NAT instances. Or you can build your own. You don't have to use their pre-built NAT instances, to where you attach a public IP address. This is where your Elastic IP address goes, not here. And then allow this guy to be the gateway for these database servers. So it goes out here, gets NATed to the internet, and is hidden behind a type of firewall to where nobody's coming in that's not invited. That's a good thing, right? You also, when you are in virtual private cloud, can use Elastic load balancers privately. Now in this picture, it doesn't make much sense. You're like, I don't get it. But then you start realizing, oh wait, I have web servers sitting up here in this public subnet, and they're actually forwarding their requests to that Elastic load balancer. Okay, now I get it, because that load balances between the two database servers and provides a level of redundancy. So if this one goes down, we can fail over and start using this one for all requests until the other one comes back online. Okay, got it. So that's good that the Elastic load balancer is there, but we're talking about high availability here. This NAT instance does introduce a single point of failure. Now, stop right there, hold the phone. That may be okay. I just want to highlight that. And I know a lot of people are like, oh, you said a single point of failure is okay. That's not okay. Well, remember, this NAT instance is costing you money to run that. And internet access on these may be a luxury. You may not have to have internet access except when you're running updates or patches or something like that. So you may just say, you know what? I could make this redundant, and I'm going to show you how to do that in just a moment. But think it through first and say, do I really need that? I mean, if I lose internet access, you might be like, oh, bummer. Okay, well, let's just, shut it down and reboot it and see if that, oh, yeah, that fixed it. Okay, and that saves us, a couple $100 a month. Well, if you're using a big instance, because I don't have to have redundant NAT servers running. So let me show you a very cost-effective, and I'll put quote-unquote, highly available NAT server design. What you can do is run your NAT servers in an auto-scaling group. Auto-scaling group being something that allows you to spin up instances based on a minimum and maximum requirement. So I create the group, if you haven't seen an auto-scaling group before, an auto-scaling group, and I say, okay, the minimum on this, and what I'm going to design here, is a minimum and maximum will be 1. So there must be always one server running. So if that server goes down, and you can have health checks or whatever else identify that that server is down, you can quickly have the system automatically terminate it, toast, it's gone, and then spin another one up to take its place, and everything starts running. Now, will that cause some downtime? Yeah, kind of. Meaning, just like I was saying before, the NAT will be down, the quote-unquote internet access will be down for your database servers, but maybe you don't care. Again, maybe this is not a high priority thing. You've just got web servers focusing in on that ELB, distributing their requests down there. Internet access is a luxury. Well, then I'm totally cool setting up an auto-scaling group behind the scenes to just monitor and terminate and bring those back up with a couple minutes of downtime, and that could be okay. So if you are going to use an auto-scaling group, you do have to configure it to auto-build your NAT server. This is where you get into some of the API calls, to where it will actually take the Elastic Network interface from the old one, remove it, put it on the new one, kind of bolt it back on there. For some reason, I just think of a car assembly line every time I think of this. The API calls can also modify your routing table to forward traffic through that new NAT instance, and then you can have it bootstrap the NAT device. If you haven't heard of bootstrapping before, essentially that's applying updates or essentially building the device as it boots. So you start off with an AMI, an Amazon Machine Image, that says, okay, this is my NAT device, but as it boots up, I have it attach the right cards, I have it modify the routing table, I have it apply some updates, I have it install whatever caching server I want to on there. That's the idea of bootstrapping. If the always-on internet access is critical for these behind-the-scenes devices, then set up 2 of them. Set up 2 NAT instances in an auto-scaling group that if any one of those goes down, auto-scaling detects it, terminates it, and spins up another instance and adds it to that group as it goes. There's actually, if you go to Google and type in AWS Squid Server design. Squid Server is actually a Linux-based caching server where it can cache internet content and all that kind of stuff. I mean, it gets even better because, maybe these guys are Ubuntu servers and you have to apply updates. Well, the cool thing is you only have to download those updates once, and then you've got screaming fast access to those updates for the database servers. Just give you an example of that. We just got, we're at the end of 2014 right now, the Shell Shock. Have you guys heard of this? This is the 20 years in the making security vulnerability that was found in the bash, essentially shell that runs a lot of Ubuntu instances. And so this is essentially allowing anybody to execute commands from the bash if they use this specially crafted string, right? So we, actually me, just had to patch a whole bunch of Ubuntu servers, not just 2, I'm talking more on the lines of 50 of them. And so if I had a Squid server in front of that, that would save me all that download time waiting for all those updates to download. It would download once and then high speed feed those to all the different devices. So let's move from the network redundancy into application redundancy or high availability. How do you make your applications or whatever you're hosting in Amazon Web Services highly available? Well, first off, best practice always is to use EC2 instances in multiple data centers or availability zones, and use elastic load balancing to take the incoming load and distribute it between those. It also does health checks on these guys, so if one of them falls out or an entire region or data center goes down, which has happened in the Amazon Web Services world, it can flip over and use a different data center and keep everything running, right? So I will say, let me just do a quick aside, what about that? I've seen a lot of people, if you go to Google and type in, is an elastic load balancer redundant in itself? The answer is, yes. What do you say? I don't know. It's magical. It's a magical device that Amazon says it won't go down, but we'll again look more as we continue through this at some high availability designs that even bring in HA for the elastic load balancer itself, right? So data, as you start growing your design will start to get a little heavy on the web servers. Essentially, whatever is serving your content out may start to get overloaded, and then you start running into the, well, how do I repair it if it goes down, right? So let's just say this instance terminates, and you've got all kinds of content that you have to load back on there that's constantly updating, it's dynamic. Well, you have to bootstrap that thing, so as it boots up, it copies it all from some data source, which could take a lot of time as it moves from the gigabytes into the terabyte sizes of data. So what Amazon says is, you know what? Put all your static assets, not necessarily always static, meaning something that is generated and becomes something like an image, a web page, whatever, put it in S3. S3, number one, minimizes the load on your web servers, minimizes how much data is on those guys and how much access it is. And remember, S3 is directly web accessible by itself. S3 is not only a content store, it is a web accessible web server with 11 nines of availability. 99.9999999% uptime, because it's distributed between multiple data centers, at least 3 different data centers, anytime you store something in S3. So it's crazy redundant. And then if that slows down in itself, because S3 has throttles, it has limitations, you can start integrating that with CloudFront. What is CloudFront? CloudFront is the essentially load distribution for web content, allowing you to cache your web content worldwide at all these different CloudFront sites. So essentially, as you are sitting here in the world, it will access it from S3. This is the most terrible world I've ever drawn. S3, the first time, maybe that S3 bucket is in a California region, and the first time it's accessed, it will be copied over to the CloudFront distribution over here in Japan, over there, and from there on out will be served from the CloudFront Center of Japan. So this is your way of making these guys not only highly available, but also alleviating the amount of load on them. Because remember, anytime you think about high availability, you have to think not only of keeping your machines online, that's probably 20% of high availability, but keeping them available from the sense that you don't overload them, causing to go down virtually, because it's almost a denial of service because there's so much load on your devices. Now, there will be a time where you cross the line of state sharing, meaning whenever you are serving content, web services or whatever, you often will store cookies or state information for the users in the web server instance itself. As you start to scale horizontally, which is the Amazon design of just adding more and more and more and more and more web servers, distributing it horizontally instead of growing these vertically, adding bigger and bigger and bigger servers able to handle more and more load, they spread it wide, right? The web servers itself store session state information. Now, what that does is lock users into that web server, which undermines some of the load balancing you're able to do. Then you have to do sticky sessions and static sessions, so they always end up on the same web instance, and that doesn't scale, because what if you have a handful of users that really start hammering a web server? You can't start distributing them because all their state information resides on that web instance itself, and it will cause an interruption of service to them. You know, it logs them out of the website, or it cuts into their video stream or whatever if you shift them over to a different web server. Solution. You're probably just like, I've already read ahead of you, Jeremy. You don't have to tell me. I've read it right there. Reconfigure your applications to store the session state information in an highly available Ninja Fast database. That's the whole idea of DynamoDB. That thing is ninja fast. It's actually a NoSQL database available from Amazon Web Services. So instead of storing the state information right on the web instance itself, you store it with this high-speed Dynamo database, so you don't see any impact from the user perspective. But that then creates yet another tie away from the web server itself. So if the web server goes down or gets overloaded and you have to shift users to a different one, it's all referencing a database behind the scenes with the state information, so it can be seamless. As we talk of all this high availability, I have to add in a little side note on bootstrapping versus what's called golden AMIs. AMI is an Amazon machine image, and a golden AMI refers to a perfect image, meaning I've got this, let's just say, Ubuntu instance that serves all my web content. So I create this version 1.1.2 of my golden AMI, and I've got all these web servers, and any single time one of those web servers goes down, or maybe have to scale because I'm in an auto scaling group and I have to add more web servers into that mix, I can just take that golden AMI, make a copy of it, and boot up another web server that's, bam, ready to start running right from there. The beauty of Amazon, I should say the golden AMI design, is these things boot, they replicate lightning fast. The drawback is you start having to update that thing constantly. The bigger and more complex your web service becomes, I mean, just take, for instance, I just mentioned shell shock, the vulnerability that was exposed just a little bit ago of all these Ubuntu instances. I have to go through and update all my AMIs of all my different devices to accommodate for that shell shock, versus bootstrapping being applying patches as the instance boots. The best, so let me talk a little bit about that. There is a purist mindset out there to where you can say, I don't even want an AMI, or maybe my AMI is nothing but the base Ubuntu or Windows Server operating system, right? And as I click that machine's on, I have engineered scripts, and I've got updates and copy task and cron jobs and everything else that by the time that machine boots, I've essentially assembly line built this instance. Now, I will tell you, bootstrapping is one of the most coolest, time-consuming, puzzle-building things that you can do. Meaning, as you do it, if you haven't bootstrapped a device before, I highly encourage it, but just make sure your family knows, because you'll get addicted. You're like, oh, because you do it and it doesn't work. You're like, oh, it didn't work. Okay, well, let's, wait, no, if I add a semicolon right there, oh, wait, let's try. Oh, it worked. Look at that. But hey, I can make it even better. And then you start creating this script of all scripts that boots the device. Two drawbacks to that. And you're like, where's he going? Two drawbacks to that. One, your time. It takes a long time to figure out the best way to bootstrap these devices, because it can be a constant. I mean, essentially, you're building an assembly line for computers, right? That's what bootstrapping is. The second problem is, even when you do figure out this glorious script, the time it takes to actually get this guy from zero to hero becomes prohibiting. I mean, let's say you've got an auto-scaling group of 2 servers, right, that balance the load. One of them goes down in a blaze of glory because the server it was running on crashed. Well, if you bootstrap it completely from scratch, it might be half an hour before that server's back up and running again, because you have to download all the updates and patches and all that. So what is Amazon's best method? Don't have this be a versus. Have this be a both and. Meaning, you create a golden, or I'll say, maybe it's like a tarnished, it's like an almost golden AMI that has most of what you need. It has most updates. It has most of the web server files. Essentially, the stuff that stays the most static goes into an Amazon machine image, right? An AWS AMI. Right? Goes into that, and as you boot that, you apply some bootstrapping to apply the latest and greatest updates, or the latest and greatest web config files, or the latest and greatest API calls that add that into the load balancing, elastic load balancing group, so the machine can start receiving those updates. We have seen one high availability slide after another through this entire nugget. So let me take a moment here and put it all together. Look with me. We've got an AWS region, AWS East in this case, but it could be any region that we're talking about. And inside of there, I've got a whole bunch of availability zones, or at least subnets within them. I've got some public-facing availability zones right here, the web services in Data Center 1 and Data Center 2, right? And you can see the associated subnet. So these essentially are being load balanced between using the public-facing load balancer. We'll put an elastic IP address right here on the ELB. It's coming in, bouncing between these guys. If the entire data center goes down, that's cool. It's not cool, but we can fail over to data center number 2, serving the same web content from the same databases. So I can have a highly available database instance behind the scenes, one in one data center, one in another. So I can hit this load balancer, which is doing health checks all the time and load balancing between these database servers, So, I can have an entire farm of web servers go down and still be using the database servers in that availability zone, or flipping right down in the same AZ2 data center as the web servers, right? So that in itself is a great high availability design right there. But what about this elastic load balancer instance right there? Well, as I mentioned before, Amazon says it's magical. It's a magical device that just doesn't go down. And we all say, oh, okay. Well, if you're like me, there's only so much magic words that you can get before you're like, I want to know. I want to make sure. So you could either A, set up another ELB, and start using Route 53 to bounce between them. Route 53 being the DNS services of Amazon Web Services that allows you to do health checks. And I can say, okay, let's watch that ELB. And if that goes down, I'm going to point the DNS records over to this ELB. Now, it's not going to be as fast as of a failover because of the caching time, the time to live on your AWS DNS records, right? So if those are 5 minutes, then you've got 5 minutes before the world starts failing over to use this alternate route. But that would be another way that we could add a layer of redundancy. Or the final failover recommendation might be a static S3 site. Right? So you can actually have, and Amazon recommends doing this, all your dynamic content and all that kind of stuff generating on these web servers. But maybe you're saying, you know what? If the index page isn't showing up right, or if this, you can have health checks coming from this guy that says, okay, if I'm seeing, this page is missing, or I get a page cannot be displayed or something, maybe all my servers are running just fine. So the health checks otherwise say, yeah, life is good, but maybe I misconfigured something. Maybe I went in there in the database and forgot to, fill it in. Whatever the case is, you can have this guy doing a health check that says, you know what, if all the redundancy is there and everything's running, I'm still seeing this page not showing up. Let's fail over to a static version of your website running from S3. It may not be fully functional. It may be a placeholder that says, hey, we're down for maintenance. It may be as big and glorious or as small and trivial as you want it, but it's a whole lot better than somebody going to your website and seeing it spin and spin and spin, and then it goes, shoom, sorry, page cannot be displayed. You know how that makes everybody feel, right? So even we are temporarily having a maintenance window right now, sorry for the inconvenience, way better than having your web server not show up at all. I feel so good going through this nugget, and at the same time so hesitant because I feel like I've just opened up 15 cans of worms of like, oh, but wait, what about this, and how can I do that, and there's so many directions we can go with the information that you now have. But the key is I've laid the foundation for you. You've seen the concepts behind high availability and how to design it in Amazon Web Services, both from starting off with the direct connect, it feels so long ago for some reason, into high availability NAT, into application high availability and multiple EC2 instances, ELBs, into session state high availability, into elastic network interfaces. Essentially all the pieces of high availability have been laid out on the table for you, and it's kind of like a shop where you go, oh, I like that one, and ooh, can I take that and put it together with this? Yes, you can. That's where you start creating your own design and figuring out the intricacies of how that high availability can be integrated into your setup. I hope this has been informative for you, and I'd like to thank you for viewing.